Okay, so there are 8 theorems that you need to learn. However, from the 8, only 7 really come up. Okay, so I'm not going to go through the 8th one just yet. I think if you master these 7 that we're going to go through, then I think you've actually got it. So I'm going to go through each one. And I'm going to set some examples for you and kind of show it to you how you should be spotting it. Now, circle theorem is a topic that, if you're doing it on the higher paper, if they ask you one of the theorems, okay, they don't tell you which one, you have to actually know from the 7 or 8. Is you have to kind of spot patterns to know what theorem it is. And where you get one of the marks is for one of the answers for the angle, but you get another mark for giving a reason. Now on the higher paper, they don't like to just give you one theorem. They like to give you one circle, but it might have 2, 3, 4 theorems in there. I've seen it go up to maybe 3 theorems, not 4, but for each theorem, they'll say give a reason for your answer. Okay, so you need to know the explanation behind it, and the reasons are given as you can see on this first page. But let's have a look at each of them. There's no particular order, by the way, when you learn circle theorems. You just have to spot a pattern. So the first one I want to start with is, let me start with this one over here. This is the only theorem that involves a diameter. And how do you know it's a diameter? Because it will go through the middle. It's the only theorem that involves a diameter. If you look at all the other ones, here we go, look at all the other ones. There's no diameter involved in there. There's radiuses, but there's no diameters involved. So this is the only theorem that's with diameter. That's why I went through that one first. So in simple terms, I'm going to make it kind of childish and easy. Then obviously you learn the theorems. If you've got a diameter, which is here, the angle that's opposite the diameter will always be 90 degrees in a circle. Okay, that's for a triangle. It will always be 90 degrees. But how you have to learn it is the theorem that's on the top here. When they ask for what reason, okay, why is that 90? It's because angles subtended at the circumference by a semicircle is 90 degrees. If that seems too hard to write down or remember, you can say angle in a semicircle is equal to 90 degrees. Obviously, the proper words is subtended at a circumference, okay, by a semicircle, but you have to use the word semicircle in there. So angle in a semicircle, okay, angle in a semicircle. And why is it a semicircle though? Because think about it this way. If the diameter covers half a circle, then you're left with an entire semicircle, correct? And therefore the triangle is part of that semicircle. That's why there's an angle that's subtended in that circumference. And a circumference, just to keep it really clear, a circumference is the angle that's where it touches any point around the edge. So any point around the edge, the perimeter, okay, is the circumference. So you need to know that theorem. That's why I've done that one first. The next one that you need to learn, that I'll make you do, it's a nice easy one. It's any four-sided shape, 1, 2, 3, four-sided shape. A four-sided shape inside a circle is called a cyclic quadrilateral. So cyclic, you can see, means it's for circular, and quadrilateral is four-sided shape. But you have to say the definition correctly. That opposite angles, there we go, those two are opposite, A and C, okay, they add up to 180. You can't say that opposite angles equals 180. You need to say that they are the sum of, or they add up to 180 degrees. Do not say they're equal to 180, they add up to make 180, okay? So you don't have to say A and C, you just need to say opposite angles in a cyclic quadrilateral equals 180. Okay, and it's the only one that's got a four-sided shape in there. Okay, that's why I've covered those two first. So if you ever see a four-sided shape, cyclic quadrilateral, that's the theorem for it. Okay, the next one that I want you to have a look at, and this is my favorite theorem, by the way. In this entire thing, by the way, I'll just make clear. Have a look at this one. You've got a radius here, and look here, you've got a radius here. Okay. Now, I'm going to come to this one in a second because there's something I'll show you a short way how to learn this one. I'm going to show you this one here. This is actually my favorite theorem. This one comes up a lot, but it's hidden a lot, as in like it's there, but people take it for granted. When the radius and the tangent meet, okay, it will always equal 90 degrees. Exactly what it says here. Tangents and radii. Radii means it's one. Okay, when they meet, it's plural, sorry, in that, so that when it meets, it is equal to 90 degrees. Okay, so here we go. If I draw another circle here and draw the radius going at the top, and there's a tangent, and where they meet, that will always equal 90 degrees. So when the radius meets the tangent, it always equals 90 degrees. Okay, So we've done 3 theorems so far. The next one that you need to know is, which we'll do, right? I can link these two together actually. So let me explain how this is done. If I take these 2 points on the circumference, okay, I always do this. Try and do this while you're watching the video, so it's easier for you, okay? Put one finger, your left hand finger, one of your fingers from your left hand, put it on this point here on the circumference. Then take your right hand finger and put it on this point here. Okay, now what you do is you're going to move both fingers together, simultaneously together. And what you do is this: you take both fingers, I'll try it myself here, and you move it. Oops, sorry, I'm moving the whole thing. You move it up. So you move your left finger going up, and at the same time move your right finger going up. Move your left finger up and your right finger. And if you notice, both of them meet here to form an angle at the top. Okay, once you have done that, I'll use another color. Because your both fingers now meet here, okay, they form that angle at the top on the circumference. If you move both fingers back down, I'll use blue, so that one goes down, that one goes down, that one goes down, and that one goes down. You end up back at the same place. If you take both points, I'll use another color. If you now take both points and move to the center, only the center, okay, remember the center has got a dot in there or 0, they tell you that's the center. If you move at the center, but it has to be from the same 2 points, okay, then that tells us that the angle at the center is double or twice the angle at the circumference. So what we're saying is, if this angle here is x, then this angle at the center will be twice x, only if the 2 lines are at the same point. Okay, be careful with that one. And how you should know roughly how it looks, that's the one where the angle is twice the angle at the circumference, is because it looks like an arrowhead. Okay, so if you look at the design of it, you can see, I'll just draw it in yellow, it looks like an arrowhead. Okay, so that kind of gives it away, but sometimes they try and trick you around with that. The reason why I linked it to the one at the bottom is because I want you to take your finger again, your left finger, and I want you to put it on this point over here. Okay, and I want you to take your other right hand finger and put it on this side over here. Now what you do is you take the 2 fingers for a walk to make an angle at the circumference. So if I take this one over here and this one up here, it forms an angle. Okay, let's just call it x. We don't know what it is. It could be 30 degrees, could be 28 degrees, doesn't matter. It forms an angle. We're then going to take those 2 points and we're going to go back here, back home. There we go. So we've come back home to here, the starting position. Keep your fingers on there though, don't move it from there. Then you take your fingers from those 2 same points for another walk. So if I go up here and I go up here and then go for another walk, it forms an angle. Guess what? Because you've taken it from the exact same 2 points from here, okay, therefore this angle will equal this angle. Hold on, what if I took this point and took it for another walk from the same 2 points? Therefore, this angle here will also equal this angle, which equals this angle. You could, if you wanted, take these 2 points for another walk. Okay, if I took it here, sorry, up here, and if I took that point here, and it forms another angle, that will also be x. Okay, so you need to learn how to do that one as well. You take them for walks. Okay, this one does not have to involve, the center. Okay, this is why it says angles in the same segment are equal. Same segment because they're from the same 2 points. Okay, but when you're trying to explain it to your teacher, you can't say it's from the same 2 points. You have to just say angles in the same segment are equal. Okay, the next one you need to do, now if you look at it, I made you do this one here earlier, which was this is one I really like. Radius meets the tangent. Now if you notice, this one's got tangent, this has got a tangent, and this has got a tangent. So from the 7 that you need to learn, 3 of them have got tangents. So if you see a question in the exam paper and it's got a tangent, you can kind of eliminate others and start working on these 3 as a priority. You know one of these will come. So we've done one of them where radius meets tangent. The next one here, let's do the one on the top right, this one here. I'll use yellow because they've used green. Okay, what they're saying is if you've got a tangent on the outside and you've got another tangent on the outside and they meet at a point, it means that these 2 lengths will be exactly the same. Okay, will be exactly the same. So what's the purpose of this theorem? What is the, what's the idea of having that theorem? Here's the idea. If I've got a center, let's put a dot here in the middle. If I've got a center and I draw, a line here and I draw another line here, do you agree that this is a radius and this is a tangent. And when the radius meets the tangent, look here, when the radius meets the tangent, it will make 90 degrees. So this here will be 90 degrees. There you go. And then on this side, you've got a radius and it meets a tangent. This will also be 90 degrees. So if they by chance give you this angle up here, you should be able to know what this angle down here is, or vice versa, because it's a four-sided shape, and a four-sided adds up to 360. But again, what is the point of knowing that the two tangents are equal? Because if I drew a line and I split it like that, I'll use another color actually, split it like that, I form a triangle. What kind of triangle though? It becomes an isosceles triangle. So if I know what this angle and this angle is, I should know what the top angle is. But you need to know that when two tangents meet outside at a point, they are equal in length. Okay, and if they're equal in length, then the inside you can start forming isosceles triangles. The last one, okay, that you need to learn. Now, we did this with angles, if you remember. If you've got, I'll draw two parallel lines. If you've got two parallel lines and you've got a line cutting it, and you say, do you remember we did Z angles? Okay, and for parallel lines. Now, in a Z angle, the inside of a Z is equal to the inside of the other Z. We remember that, yeah? And that's called alternate angles, okay? So alternate angles is when the inside equals the inside. With circle theorem, slightly different. Let me use a different color. Let me use a dark color. Okay, involves the tangent. It's a Z again. Watch this. 1, 2, 3. I don't like this one. I'm going to use a red actually because it's more brighter. 1, 2, 3. Now the difference with this is, look, you've got a Z here. The inside, okay, please learn this. The inside of where there's a tangent is equal to the outside, not the inside. So the inside has to be within the tangent. Okay, so if you look at this, the diagram I've done, I'll do it in red again. 1, 2, 3. You always start with the inside of the tangent. That's the inside of the Z. So it belongs to the tangent, and this is the outside. But how do we know how far we have to go? You can't go up to the circle. There'll always be some sort of triangle type shape, okay? And it will block off on this line here. So that Y is equal to that Y. If I did the Z the other way, 1, 2, 3. The inside, there you go, there's the inside is equal to the outside. How far do I have to go? Look, there's another green line here. So I know I have to stop up to there. So this is called the alternate segment theorem. So you can still use the word alternate because we said alternate angles, but it's called the alternate segment theorem. That's it. That's the only reason you have to write. You don't have to explain it. You don't have to explain that the inside of a tangent is equal to the... Don't explain. That's for you. It's just called the alternate segment theorem. So these are the 7 theorems you have to learn. If we go to this, I'll show you an example. Now, one of the things that I always tell my students when they do circle theorem is this. Whenever you've got a circle theorem, you must learn this. If you've got a circle and you've got 2 radiuses, think about it this way, yeah? If I've got a circle and I've got a radius, there's a radius, and I've got a radius here, okay? And I draw a line and connect it, it means that these 2 lengths must be the same because they're both radiuses. They have the same length. Therefore, this becomes an isosceles triangle. Always remember that. It's not part of the theorem, by the way, but you have to learn that because isosceles triangle comes always in circle theorems. So if you look at this, that's a radius and that's a radius. If that's a radius and a radius, that means that's an isosceles triangle. So that one here is 180, okay? Take away the 130, which gives you 50 degrees. And then if you split the 50 degrees up, that is A and that's your B. Okay, again, you can do the same here. If that's 30 degrees, then this side here must be 30 because it's an isosceles triangle, so you should be able to work out B. Here, for example 3, if that's 80 degrees, angles on a straight line, remember, at a point. If that's 80 degrees, then that A must be 100 to make 180, and then you should be able to work out B and C because it's an isosceles. Again, the same here. Have a look. I like the way they've done this one. Be careful. There's the center. There's a radius, so that's one isosceles triangle. But hold on, look, they're so smart. They've got a radius here and a radius here, so there's another isosceles triangle. And also because you've got an angle on a straight line, then therefore that should equal 180 as well. Okay, so you can work out different things. You just need to learn that thing. If we look at this question over here, I've noticed one thing. Look again, I'm just looking around. There's no tangents in this involved, so that eliminates 3 theorems straight away. That's the best way to do it. But if you notice, it's the, look, I can see a diameter here. I can see a diameter here. I can see a diameter here. There's only one theorem that's got diameter, and it's the one that said okay, that the angle that's subtended, remember that one, in a semicircle, okay, is equal to 90. It's the one that's opposite is always equal to 90. So you can fill that in and then work out the rest. I'm going to leave that one with you, but I really want you to think about that. So here you've got two triangles, but they're both subtended with this diameter. So there's a 90 there, there's a 90. They should be able to work it out and fill in the rest. I will leave that thought with you as well. And then don't forget things like little things like angles on a straight line add up to 180. Have a look at this one. What I can see when I'm looking around, on the first lot, there's no tangents at all. However, I can see four-sided shapes. And there's only one thing that we learned with four-sided shapes is angles in a cyclic quadrilateral, okay, add up, or the sum of it is 180. And remember, it's always the opposite that they're asking, the opposite, the opposites, okay? Focus on the opposites, okay? And then write, and next to it, when you not only just do it, you have to write the theorem. Try and practice writing the theorems all the time. It stays in your head then. The less you write it, the worse it is. The next one that you've got here, you can pause these videos anytime, okay, and then just carry on and do the questions if it helps you. This one here looks like a bow. We did this, sorry, if I go back here, it says here, I never showed this bit, did I? Look for the bow shape, okay? Anything that's a bow shape, there we go, okay, that looks like a bow tie. Okay, this is the one where you take your fingers for a walk. Now, if you think about it, this is 30 degrees given here, and we have to work out A. Forget A means nothing. Let's look at 30. How is 30 degrees made? It's made from these two lines. So if I go here, back here, take it for a walk and go back here to the circumference and take this line here, okay, they both meet at these 2 points. What if I take these 2 points for a walk around the circle somewhere? I can go up here and I can go here. I can go here and I can go here, and they both meet here. What does that tell me about this 30 degrees and this A? Go take it for a walk. Same with these. This 61 degrees is made using this point and this point, because this line goes here and this line goes here. Go take it for a walk. Okay, I'm going to leave that with you. How do you make 31 degrees? It's made from this line here and this line here. So it's this point here and this point here. I like to draw the little circles in here. Then go take it for another walk. There you go. You can go anywhere around the circle and go for a walk. But always find the 2 points that make up an angle. Go back to the circumference from those 2 lines and go for somewhere else for a walk. You'll find it. It starts getting a bit more complicated with example 3 and 4. Have a go at that. Okay, so this one over here, interesting. I like this one as well. I'm just flicking around this. I can see again there's no tangents in this, so it eliminates the 3. What I can do is this though. There we go. You've got 2 points that meet here, and they meet at the center. And if you go up here, there's the arrowhead. Okay, the angle at the center is twice the angle than at the circumference. So this will always be double than this angle over here. Okay, you can go around, have a look at it. What I've noticed also, look here, there you go. You've got it here again, there's 70, and then this has to be half of that because the angle at the center is double. But what I've also noticed is, have a look, there's 2 radiuses, they meet here, there's your isosceles triangle again. So you can work out what B is as well. Okay, the one that's the tricky one, I love this one, okay, it's example 4. And they try and trick you with this. What they do is, there we go. If that's 78, what is this angle here, A? That's going to be double the angle, isn't it? Okay. So if that's 78, then this is 156, because it's twice the angle. But also, look at what they've done here. They're so smart. If I take this point here, this is angle at the center. But if I go back home, just go back. If I go back home to this point and take it for another walk, I'll use a different color. Look, I'll take it there and I'll take it up here, and it makes B. So angle at the center is twice the angle at the circumference. Now it's supposed to look like an arrowhead, but look what they did. They took the circle. I'll draw it here better. There we go. There's angle at the center, but look what they did. They went back home. There's the dot. There's the dot. And they, instead of taking it up, normally they'd always take it up here, so it looks like an arrowhead. They took it to the side, but they can, because the theorem is still the same, that the angle at the center is twice the angle at the circumference. There's a circumference over here. So just be a bit careful with that as well, on how this works. Okay. Let's have a look at this one. Right, now some tangents are involved on this, so we've got to be a bit careful. What's the first tangent theorem you should always think about is radius meets tangent. That's my favorite one. Okay, so we always try and go for that if possible. So we've got here, look at that. There's a radius because there's a center, and there is there. So you can know that's 90 degrees. Put that in, then you get a mark already just for that, for putting the 90, and for saying that radius means tangent is 90, and you should be able to fill the rest in as well. Again here, radius means tangent, fill it in as well. Now, this is the one. The example 3. Two tangents on the outside are equal in length. So this here is 46 degrees, okay? So if that's 46 degrees and they've drawn a line here, you should be able to work out what C is and what B is, because this becomes an isosceles triangle because the tangents are two same in length. So you should be able to work out what C is and what B is as well, okay? Now, some students have actually got this one wrong. Watch this, yeah? They've said to me, sir, sorry, let me just do this one again, undo it. There we go. They've said, let me just enlarge this actually, this one here. They've said, sir, you've got one here, there's 46 degrees. Isn't that cyclic quadrilateral because it's opposite? And I said to them, no, because the four-sided shape, this four-sided shape has to be in the circle to be a cyclic quadrilateral. This part of the shape is outside this. So please don't do that, okay? So they said, okay, so what do we do then? So I said, okay, no problem. So what you do is this, think about this here. You should be able to work out C and B. Now let's ignore C and B. However, what you should do is this. Here's radius meets the tangent. Look at that again. So that whole angle becomes 90 where the radius and tangent meet. Here again, radius meets the tangent, so that becomes 90. Here's the four-sided shape. Guess what? When a four-sided shape adds up to 360, you've got 46 degrees, you've got 90 degrees, you've got 90 degrees. Now you can work out what A is because that makes your 360 degrees. They love this question, by the way. They love asking this question a lot, and they like to challenge you on that. Okay, so just be a bit careful. You can do that. Same with this one, just on the bottom here as well. There's 24 degrees. Radius means tangent. Radius means tangent. Put the 90 degrees in, and you should be able to work out what A is. Once you work out what A is, if they want B, so you should be able to work out what A is when they want B, angles in a circle from a point 360. I'll let you work out the rest because I think it starts becoming common sense. Right, this is the one that confuses people. There's a triangle. I told you they love putting triangles in here. There's another triangle. There's another triangle. There's a triangle. There's a triangle. There's a triangle. And they've got a tangent. And then therefore, this is the one where the alternate segment theorem. So how do you do an alternate segment theorem? Find where they have given you an angle. Let me just enlarge this for a second, then I'll bring it back. So here is your tangent, and there's your 28. That's where it meets. 1, 2, 3. So the inside is not equal to this inside. Don't get that wrong, please. This is wrong. Okay, the inside is equal to this outside. And where do we stop? Up to here. So there's your A. So this 28 is this 28. And what's the reason? Because it's a alternate segment theorem. Again, here you've got 65 here, so we can do that and that. So this 65 inside, keep it in your head, inside is equal to this outside A. So that equals 65. But if we do the theorem the other way, 1, 2, 3, look, I'm drawing this heads. The inside here is equal to this outside. So I'll let you work out the rest on these, but it's called the alternate segment theorem. So you can pause it, have a go, do what you need to. They've given some clues, hints and stuff. I love when they give you these kind of things here as well. That tells you they're isosceles. If they're isosceles, you should be able to work it out by filling in the missing blanks. Okay, so I've gone through all the theorems with you. Pause the video wherever you need to and have a go, but everything is based on this. I recommend drawing this and so it stays in your head, but you've got to learn the reasoning. Reasoning is the most important thing. Okay, have a good holiday.